Simultaneous equations. We're first going to do the elimination method, and then later on we'll do the substitution method. In different situations, one will be easier than the other. For the elimination method, generally speaking, you want to see something where the coefficients or the numbers next to the variables are exactly the same, because it's easy to eliminate and then solve for x and y. You have equation 1, which is x plus 3y equals 9, equation 2, x plus y equals 6. The variables here have the same coefficients, which are 1, which means that you can subtract each of the parts from each other. So x minus x plus 3y minus y, which equals 9 minus 6. X minus x disappears, 3y minus y is 2y, and 9 minus 6 is 3. Therefore, if we divide both sides by 2, eliminating the 2 on the left-hand side, y would equal 3 over 2, or 1.5. We now know what the answer is for y, so the solution is for y, so we can substitute it into any of these two equations. So I'm going to pick equation 2. So let's substitute y equals 1.5 or 3 over 2 into 2. So you'll have x plus 3 over 2, which equals 6. If we now subtract 1.5 or 3 over 2 from both sides, we're going to get x plus 3 over 2 minus 3 over 2, which equals 6 minus 3 over 2. This would cancel that out, and 6 minus 1.5 would be 4.5, so x would equal 4.5. So now we have a solution for x, and we have a solution for y. In this example, the coefficients are similar, but not, because this is minus 2, and this is positive 2. This has obviously got a 1 in front of it, and this has a 5. So you can either multiply everything here by minus 1, or multiply everything here by minus 1. So I'm going to take 5p, minus 2q equals 19, and multiply every part by 1. So 1 would then become minus 5p plus 2q, which equals minus 19. Now, this coefficient is the exact same value as this coefficient. So if we subtract the first from the second, you're now going to get minus 5p minus p, 2q minus 2q, and minus 19 minus 11. Minus 5p minus p is minus 6p. 2q minus 2q vanishes. And then minus 19 minus 11 would be minus 30. If we now divide both sides by minus 6, your minus 6's cancel out, and you would then get minus 30 divided by minus 6, which would be positive 5. So therefore, p would equal 5. We can now take this and substitute it into either of these simultaneous equations, and you'll get a solution for q. So I'm going to pick equation 2. So you're going to get 5 plus 2q equals 11. Let's subtract 5 from both sides. So you're going to get 5 minus 5 plus 2q equals 11 minus 5. These vanish, and you'll be left with 2q equals 11 minus 5, which is 6. We divide both sides by 2. These disappear, and you'll get q, which equals 6 over 2, which is 3. So we now have both of our solutions for p and q. we don't have any coefficients next to the x or y term that are similar. So what we need to do is multiply the second equation by either 3 or 7 so that the x can be the same or the y can be the same. So I'm going to multiply equation 2 by 3. So let's take equation 2 and multiply it by 3, which is going to be 3x plus 3y, which equals minus 33. We can now subtract 1 from 2. So 3x plus 7y equals 13 minus 3x minus 3y, which equals minus 33. 3x minus 3x, 7y minus 3y, and then we'll have 13 minus 33, which is going to be positive 33. So now we can clean up. So 7y minus 3y is 4y, and 13 plus 33 is going to be 46. If we divide both sides by 4, you'll get y equals 46 over 4, which is the same as 23 over 2, or 11.5. We now take this value for y and we substitute it in to any equation. So I'm going to pick the easiest one, which is equation 2. So you're going to get x plus 11.5, which equals minus 11. Let's now subtract 11.5 from both sides. So you're going to get x plus 11.5 minus 11.5 equals minus 11 minus 11.5. This disappears, and we'll now have x equals minus 11 minus 11.5, which is the same as minus 22.5. So now x equals minus 22.5 and y equals 11.5. For the substitution method, we want to rearrange one of the equations so that it looks like y equals something or x equals something. So in this example, equation 2 looks the easiest to rearrange. I'm going to rearrange it so that it's in terms of y. So we'll subtract 2x from both sides. So that means we would then get rearranging 2 would make it y equals 5 minus 2x. This value of y is the same as the value of y here. So we can now sub 2 into 1. So 3x plus 11 brackets 5 minus 2x will equal 36. We can now expand the brackets here. So we're going to get 3x plus 55 minus 22x, which equals 36. We can now subtract minus 22x from 3x, which would leave us with minus 19x plus 55, which equals 36. If we subtract 55 from both sides, that would eliminate the 55 from the left-hand side, and you'll be left with 36 minus 55. 36 minus 55 is minus 19, so we're going to get minus 19x and minus 19 on the right-hand side. If we divide both sides by minus 19, this will cancel out, and this would equal 1. Therefore, x equals 1. We can now substitute this into any of these two equations. So in this example, I'm going to substitute it into 2. So if x equals 1, y plus 2, because 2 times 1 is 2, equals 5. We can now subtract 2 from both sides to eliminate the 2 on the left-hand side. So then you would get 5 minus 2, which means that y would equal 5 minus 2, which is 3. Therefore, y equals 3. In most cases, you will be given a question and told to solve it for x and y, and you will have to make the decision on whether you're going to use the substitution method or the elimination method. If you use the elimination method, you can't really multiply anything here with any integer so that you can get your x terms to equal 10. But you can multiply equation 1 by -2 to make your y term a positive 2, and then you can subtract. Alternatively, if you want to use the substitution method, rearranging equation 2 would make things a bit complicated because you're going to get a fraction on your right-hand side. But you can rearrange equation 1 so that it's in terms of y. Because the elimination method is generally a lot easier, I'm going to use the substitution method for this problem. So let's rearrange equation 1 so that's in terms of y. So I'm going to add y to both sides. So 10x minus y plus y would equal 3 plus y. That gets rid of the y terms on the left-hand side. And now we can subtract 3 from the right-hand side. So you're going to get 10x minus 3 will equal y. We can now take this and substitute it in to equation 2. So let's take 3x plus 2 and substitute in 10x minus 3, which all equals 17. We can expand the brackets. So we're going to get 3x plus 20x and 2 times minus 3, which is minus 6, which equals 17. We can now clean this up. So you're going to get 23x and then add 6 to both sides. So that's going to make that 23 as well. If you divide both sides by 23, it gets rid of the 23s and leaves the x on its own. So therefore, x will equal 1. We can now take this value for 1 and plug it into any of these two. It doesn't really matter which one. I don't think either one looks any easier than the other, but I'll substitute it into equation 1. So 10 times 1 is 10, minus y equals 3. We now move the y to the other side. So you'll get 10 equals 3 plus y, making y positive, and then we'll subtract 3 from both sides. So you're going to get 10 minus 3, which equals 3 minus 3 plus y. That gets rid of your 3's, and then you'll get y equals 10 minus 3. Therefore, y will equal 7.